Hello everyone, welcome to Learn Overflow. In this video, we'll discuss about today's LeetCode problem, that is the mirror reflection. So this question is a medium level question and we'll understand what this question is asking us to do, how we can think of finding a solution of this type of question. We'll understand this step by step using diagrams. I will show you diagrammatically what can be the possible situations that can arise out of this. So we'll look into those and after that, I'll try to quote our solution based on our approach that we have discussed. So before moving on, make sure to subscribe to this channel for regular LeetCode videos like this. In this video, the question says that there is a special square room with mirrors on each of the four walls. So there are mirrors on each of the four walls. So this is the four walls are there, and each of the four walls there is a mirror. There are mirrors. Okay. So further is said, except for the southeast corner, that is this particular corner, that is the diagram they're showing over here. So except for the southeast corner, there are receptors on each of the remaining corners, numbered 0, 1, 2. Okay, fine. So this is 0, this is 1, and this is 2. So here you can see there are receptors over here. Fine. Except for the southeast corner, so you can see there isn't any receptors out here. Okay. So that's what they say, that except for the southeast corner, there are receptors on each of the remaining corners, numbered 0, 1, and 2. Fine. The square room has a wall of length p. So the square room has a wall of length p. So this is a wall. Okay. Each of the wall is length p because this is a square room. Remember? So remember, each of the wall is length p. So that's the whole idea over here. Fine. So the square room has an length p. Now, further, what it has like and a laser ray from the southeast corner. So the southeast corner has a laser ray. So the ray is being directed from here. Fine. And a laser ray of length p. Sorry, laser ray from the southeast corner. Okay. This first meets the wall, the west. So this is the west wall. So a ray is directed, and you can see it meets at the wall at west. Okay. Sorry, at east wall. So this is our east wall. Fine. So that's what they say. This is the east wall, and the laser ray is directed from the southwest corner, and it meets at some point in the east. So this point at a distance of q from the 0th receptor. So from 0th receptor, it has a distance of q. Okay, so this particular distance you see over here, that's the q. Is the receptor distance. Okay, from the 0th receptor. 0th receptor, you can see here is our 0th receptor, and the distance is q. Fine. So further, the question says, given two integer p and q. So these are the two pq integer given to us. Okay, so you can see there's a p and there's a q given to us. Once we're given these two integers p and q, it should return the number of receptors that the ray first met. Okay, the number of the receptor. The number of the receptor, that doesn't mean the count, rather it means the number, like either 0 or 1 or 2, which receptor that our ray will meet. Okay, depending on exact p and q. Also, you might think that okay, the ray may not meet any receptor at any end. It may happen, but the question categorically explains that, mentions that the test cases are guaranteed so that the ray will meet. Okay, so you don't need to worry that whether they will either meet or not. So they will meet a receptor eventually. Eventually, they will meet at some places. So you can be rest assured about that. Fine. All right. So that's the whole thing over here. Now, let's understand this diagrammatically. Fine. First, look at this place. What, like this one example they given over. It says like p is 2 and q is 1. Fine. And the output is 2. How? The ray meets the receptor 2 for the first time after getting reflected from the left wall. From the left wall, it gets reflected. Okay, from the right wall, it gets reflected to the left wall. Like, see, it meets the receptor 2. So that's what we need to find out. Fine. We need to find the number. Let's try to see this problem more diagrammatically. Now see here, let's take an example where p is 3 and q is 2. Fine. P is our 3 and q is our 2. And in that case, what exactly is happening? We got our like light source at this corner. So in this corner we had our light source, right? So thus we had a light source, and further we know that after the light is being thrown to our some point over here, so this point is like this particular length is q and this particular length is p, right? So this is p and this is q. So this all we know. So the light is thrown from here, fine. Now what exactly has been done, like what exactly is done, we after the light is thrown, we know that it will reflect at, say, at any point it is being thrown. We are not bothered about what's the pq. It will reflect, right? Now it will reflect, and after it's like reflect back, then what will happen? It will reflect, and for that you will find that at some point it will like go here, and to be exact, to reflect back from here as well, right? If we just think that this will actually to be like exactly what will happen, this will reflect back from here, reflect back to somewhere like this, right? So this will happen for us, but why not, like we know that it will reflect because all the side of the square box is of mirrors. So what we can do over here, we can think of this like it is not reflecting back, rather we can extend the line forward and see how the path is going on, how we can actually visualize that. We can visualize that in this manner, that say we just create another box, like exchange this box. This is the same box, where this is number 2 point, this is number 1 point, and we're just 0 point will be somewhere over here, fine. We're just extending it in that manner, so that the reflection that was supposed to be created in this direction is actually getting created. We're just extending the line, fine. So once this extension is done, then we know that this is reflecting at some point, because this was supposed to be reflecting at some point over here further, right? So in this case, we are extending it, so we're reflecting somewhere there. So let's understand like where this reflection will end up eventually. After that, we'll find that the reflection is going straight to this corner, right? This corner. So what is this corner? I just showed this is 0 because we're just extending this. So this is 0. And if this is waiting at 0, now look carefully. What exactly happening over here is like we are kind of what we're doing, we're kind of extending the whole diagram. So what's the ultimate goal finding we have extended this p times, right? And we, if you look carefully, this small distance we had q, okay, this small distance, the distance from here to here was q, and we know that we again reflected it back. So what will be q? Q will be again this distance, right? This up to this distance, that's what it marked at q, and the q will be the final distance from uh, its reflection, right? So that will be the exact pointing of the q. Look carefully, this is normal geometry is happening, okay? So we find that the q is like we're just marking it as q because q is given to us as 2, okay? Now like why q? The answer is simple. The answer is pretty much like, if q is 2, that means look here, so this side is 3, fine. This side is 3, that means this side is 2. That's what 2 is given to us, okay? And look, and the small length will be somewhere like 1, fine. If we just draw a length from here, okay, so what will we do? This will be 1, right? This is 1. And if this whole side is p, that is 3. What is p? P is 3, and then this will again be 2, fine. So isn't this 2, 2 and 2, right? So that's the length. That's what we decided as q. We took it as q, okay? And for p, look at for p. P is something like it's going from is the length 3. So 3 is the whole length and 3 is the whole length. Fine. We got our 2 of the 3s over here. So that's what we just took the length away. Now, further look, can we think of this like uh, 2 times p, because that's the 2 times the p, the length of the p we have over here. Fine. That's the 2 times p. 2 times p is like p from here to here and p from here to here. There's a 2 times p. It's 3 times q. 3 times q, we just saw this from this from this, and this from this. So we find that 2 times p is 3 times q. So we find that that's the equality. Okay. So can we like generalize this formula? What I mean by generalizing this formula, what is this 2 and what is this 3? Okay. What are these two things? Why we're taking 2 times 3 and 2 times p? So these are the multiplication constants. Look, we need to make somehow that p and q are equal. So if this, we need to make this both sides of p and q are equal. For that, we need to multiply this because at some point, if we keep on extending, it will meet, right? If then like question says that test cases are modified in such a way that it will meet, so we take it as it will meet. So let's understand what are this multiplication constant we are going ahead with. This particular 2 we have, this particular 2 is like, look, this is like the number of time we're extending our room. Okay, this particular 2 I'm talking about, this where the number of times we're extending the room. Here, how many times we extended the room? We extended the room only once. So number of times we're extending the room plus 1. Okay, so that's the 2, right? I'll show you. I'll write this for you once more. And what is this 3? The 3 is like, see, the 3 is like the number of times the reflection is going on. How many times reflection is going on? 2 times reflection is there. So number of times reflection is going on plus 1. Okay, so let's write this diagram, like let's write the whole thing for better understanding. So we know the 2 into p equal to 3 into, what is this 2? We are taking this is the extension of into p into equal to reflection into q. So let's see. So extension, this ext variable, what is this ext variable? This is nothing but the number of room for extensions. Okay, like the number of times we are extending. I'm sorry, like number of room extensions, not for extensions. So like number of room extensions, the number of times we are extending the room. And what is this reflection? Reflection is number of reflections happening. Or how many times our reflection is happening? Our reflection is happening 2 times. So that's the number of reflections plus 1. So that's what the whole diagram was. Now look carefully, what can be the other cases? We just looked at this case. Okay, number of times p is 3 and q is 2, like the length and breadth are given to us. For that, we find that there are 2 extensions happening and 3 reflections, right? Like one time reflection, one extension plus 1, right? So extension happening 1 plus 1 2, and number this is happening this. Now look carefully, there's something you need to notice over here. Fine, this is important. What is this? If we are going with p equal to 3, q equal to 2, we are reaching at is this as 0? Fine, we're reaching at receptor 0. Now if we just modify this a bit, if p is 2 and q is 1, fine, in that case we know it's reaching at reflected 2. Fine, that's why we're reaching. But what is the extension and reflections happening? The number of times extension happening is 0, because do we need this box? Is there any need for extension? No. So what is that? 0 plus 1, that is 1. So do we know extension is happening? Plus we know that is 1. Fine. And how many times reflection is happening? Only once reflection is happening. So reflection plus 1, that's 2. Okay, that's happening over here. And for like the third case, if we need to reach at receptor 1, or receptor 1 is over here. Fine. How many times extension is happening? Our extension is happening literally 0 times. We don't need the upper extension, right? How many times reflection is happening? Is there any reflection happening? No, reflection is 0. So that's value is 1, because we just saw the value is plus 1, right? Number of reflections plus 1, number of room extensions plus 1. So that's the idea we got. Now look carefully, there's something, the trick coming up over here. Fine. The thing is, can there be any other possibilities? Is there any other possibilities? Because we need to reach 3 of the receptors. We reached all the 3 receptors. Can there be any other possibilities to reach the receptors? No. There can be 3 receptors. We can reach the 3 receptors. Fine. Now let's try to understand this. We see that when our number of extensions is even and the number of reflection is odd, then we are reaching at receptor 0. Fine. Then we are reaching at receptor 0. Okay. And when your number of extension is 1, like is odd, and number of reflection is even, then we are reaching at receptor 2. Fine. We're reaching at receptor 2. And now when both extension and reception are odd, then we are reaching at extension like receptor 1. Because both are odd, that means we are just reaching at there isn't any reflection, there isn't any extension needed. So we're directly reaching at pointer 0, pointer 1, right? Right. So that's the whole idea. Now let's generalize this. How can we do that? We can simply think that whenever our extension is even, our reflection is odd. Okay, extension even, reflection odd. We know that our receptor will be 0. Fine. Whenever our extension is odd and receptor is even, we know our receptor will be 2. Whenever extension and reflection both are odd, we know a receptor will be 1. Okay, we now know that the whole thing is going on. And what was our formula? Our formula was a p into extension, right? So p into extension equal to q into a receptor. Fine. So this was our formula. We just need to find our extension receptor. We need to keep on like run a while loop and keep on checking till we get that p into extension is equal to q into receptor. Once we get, now we need to check which is the three of the out of the three, which is the condition. Either one even, one odd, like which one is even, which one is odd, or both are odd. This cannot be a situation where both are even, because the question itself says the test cases are modified in such an order that the answer will happen in this three. Okay, like the reflection will fall on one of the receptors. Okay, that's the question says. So there's no case for or even both are even. So that's not possible. Now in that case, once we are sure about this, let's run a small while loop and let's understand how and like how what exactly this particular event, like what we are getting out of this. So let's quickly write our code and then understand it again further. So we will remember this particular formula. If I just go back once, so if I just try to go back once, so in that we'll just remember this particular formula: extension into p equal to reflection into q. So we may write that e into p and r equal into q. So that will be more or less our idea of it, right? So let's move back to our editor and understand it further. Here we are in our editor, fine. So let's just note it down that E into our P equal to this R into Q. So that's the whole idea of it. And there you see it get passed by 0 milliseconds. So what exactly we did? We simply checked our equation. This was our equation, what exactly we wrote, and we kept on increasing R. And how we find it E? We find it E through this equation, just reversing this equation. R into Q divided by P. So that was our equation. Okay, from here, E equal to R into Q divided by P. And we keep on incrementing R. So that's how we kept on doing that, and we ultimately found our E and R. Okay, once we find the invalid, we just went up checking that which is the particular case E and R are falling into. E is or even and R is odd. Result is 0. E is odd, R is odd. Result is 1. E is odd and R is even, result is 2. And this is written -1 because all these are if cases. So our code will not run unless we return something, because that's the return type we have over here. So that's the basic result. That's how you see that this runs for a 0 millisecond solution. Okay. So this is a 0 millisecond solution, and that's how we get this from here. So that's more or less about this video, guys. I hope I can make you understand how you can actually solve this code. And make sure to like this video and also subscribe to this channel for regular LeetCode videos like this. Comment down if you have any problem understanding anything. I'll be happy to help you out as well. Thank you all for watching this video.